8.2 coordinate vectors. So these are kind of similar to some of the stuff that we did yesterday in 8.1. So we're just continuing on. So component form means that you're taking a vector that has an initial point at x1, x2, and a terminal point at y1, y2, and you're translating it so that the initial point is now at 0, 0, and the terminal point is at x2 minus x1, y2 minus y1. So you're basically just shifting it. So if I kind of draw you a picture, basically shifting it from where it would be up here to where it would be down here. Same length, same direction, same angle. You're just moving it so that it's anchored at 0, 0. So if I want to find component form for number 1, all I'm going to do is take my x2 minus my x1, comma my y2 minus my y1. You need to do your terminal minus your initial. So B we're going to have as your terminal. And so your AB, your vector, gives me -3, -1. That is what we call component form. Basically, we're taking something that was not anchored at starting at 0, 0 and translating it once we know what the magnitude and direction are and translating it to 0, 0. So my vector, my component form, is 5 minus 4, -5 minus -2. So it's going to give me 1, minus the negative is plus, -3. There's my component form. Easy peasy lemon squeezy. Find each of the following for v equals to -1 and w equals -3, 5. So if you remember in class, I drew pictures of two vectors, and I said what would happen if I made one twice the size or 3 times the size. I showed you graphically, mathematically, now you're going to do it. And this should just be as simple as doing some math. So I'm doing 3 times the vector v. You get 6, -3. So that is my vector. Because as long as I give you that vector with these little arrows around it, that means it's component form. That means the initial point is at 0, 0. This is the terminal point. So if I do w minus 2 times v, that's -3, 5. I'm just going to say plus. If I distribute the -2 to this, that's -4. Distribute the -2 to this, that's +2. Or you can leave the negative here and just multiply by 2. I just find it easier to put a plus there and distribute the negatives so you don't mess them up. And then -3 plus -4 gives me -7. 5 plus 2 gives me +7. 5, I'm doing 4 times v plus 3 times w gives me 8, -4 plus -9, 15. And if I add together my x's, that's going to give me -1. If I add together my y's, that's going to give me 11. Last one, 5 times my w minus 3 times my v. So that's -15, 25 plus -6, 3. -15 plus -6 gives me -21. 25 plus 3 gives me 28. Okay, unit vectors. A unit vector is a vector that has a magnitude of 1 called a unit vector, kind of like your unit circle. A unit vector in the direction of the positive x-axis is denoted as I equals 1, 0. And a unit vector in the direction of the positive y-axis is denoted as 0, 1. So that is what we call linear form, where it has i's and j's in it. And we'll talk about that on the next screen. That's linear combination. So the vectors can be written as linear combination of unit vectors by first writing the vectors in ordered pair and then writing it as the sum of I and j. So really it's just how you represent it. You're represented as 2 vectors that have a length of 1. So to find a unit vector, you basically are going to take whatever the vector is and divide it by its magnitude. And in your book, just so that you know, they only use one bar on it. So really you're just doing the vector over its magnitude. I like to use two of them on here only because this makes you think you're doing absolute value and you're really not. But different books denote it. Some put one on it, some put two. They both just basically mean find the magnitude. Because you're basically taking something that is this length from here to here, and you're taking it down and you're shrinking it down. Let me do an arrow and I'll show you. You're taking something over here that's this length, let's say a length of 5, and you're squeezing it down to a length of 1. So it was a length of 5. Oops, let me draw. You're taking something that's a length of 5, and I'm reducing it so that it's now a length of 1 instead of a length of 5. So it was 5, and now you're basically taking whatever that endpoint is and dividing it by its magnitude to take it to a length of 1. So my vector is negative 3, 6. I'm going to divide it by its magnitude. Magnitude you get by doing Pythagorean theorem. That gives you negative 3, 6 divided by square root of 9 plus 36, which is negative 3, 6 over square root of 45. Square root of 45 is 3 root 5. So you really have 3 over 3 root 5. Square root of 45 is 3 root 5. Comma 6 over 3 root 5. And then, hold on, let me squeeze this down a little. Oops. Let me put this back up here. Well, maybe I'm not going to squeeze it down. I'll leave it. So then the 3's cancel, and I need to rationalize. So it's negative square root of 5 over 5. 3 goes into 6 twice, so that's 2 root 5 over 5. That is my unit vector. So if I were to do Pythagorean theorem on that, I would get a length of 1. You're taking it from something that has a length of 3 root 3, and you're taking it down to a length of 1. Okay, so I'm going to do the same thing here. I'm going to take my vector, divide it by its magnitude. So whatever length it was, I'm going to find the fraction of that so that I can take it down from this length to this length, or whatever direction it is. Actually, it should be negative comma negative would be down here. So I'm taking it from this length to this length so that it's a length of whatever that is to a length of 1. And so then that's negative 8 comma negative 2 over square root of 64 plus 4. That's negative 8 negative 2 over square root of 68. Oops. Square root of 68. Square root of 68 comes from doing, let me see, 4 times, okay, so square root of 68 is 4 times 17, so that gives me 2 root 17. So this is going to become negative 8 over 2 root 17, comma negative 2 over 2 root 17. 2 goes into 8 4 times, then I need to rationalize. 2 goes into 2, square root of 17 over 17. Okay. Next, I want to let DE be the vector with the initial points and terminal points. Write DE as a linear combination of the vectors I and j. So the first thing they basically want you to do first is write it in component form, and then write it in a linear combination form. So to find it in component form again, I do the n minus the beginning, the end minus the beginning. You know the n, this is your initial is the D, your terminal is the E. So that's 2 comma plus plus. Negative 7 plus 5 gives me negative 2. And so in component form, that's 2, negative 2. In linear combination form, that's 2i minus 2j. And basically, so what it looks like is 2, negative 2. Here's my vector 2, negative 2. And we already said that one vector over is I, one down is j, or horizontally is I, down is j. So if I need to go 2 over, that's 2i. If I'm going down, that's 2j. So that's minus 2j. So same thing on number 10. I'm going to do the terminal minus my initial. Oops. Terminal minus my initial. That's going to give me 9 comma negative 5. And in linear combination form, that's 9i minus 5j. Okay, component form, we already kind of talked about this the first day, so this part should be easy. Component form of a vector is basically whatever the length of magnitude of your vector is times cosine of theta, your magnitude times sine of theta. And then the angle, your direction angle, you're going to use theta, tangent of theta equals y over x. So if I want to find component form with the given magnitude and direction, remember if it's direction, direction basically means from 0 going your normal unit circle counterclockwise direction. So my vector is 12 cosine 42, 12 sine 42. I already kind of jumped the gun when we did 8-1 and did it early. And if you stick those in the calculator, making sure that your calculator is on degree mode, you get 8.92, 8.03. And then 8 cosine 132, 8 sine 132. And again, if you put those in the calculator, you're going to get negative 5.35, 5.95 for my component form vector. Okay, lastly, word problem. Anne and Henry are lifting a stone statue and moving to a location in the garden. Anne is pushing the statue with a force of 120 newtons at an angle of 60 degrees with the horizontal. So that as a vector is 120 cosine 60, 120 sine 60. While Henry is pulling with a force of 180 newtons at an angle of 40 degrees. So you have two forces acting on each other. I want to know what is the magnitude and direction of the combined forces they exert on the statue. So when I add this together in the calculator, I'm going to add 120 cosine 60 plus 180 cosine 40, and I get 197.89. And if I add together 120 sine of 60 and 180 cosine of 40, I get 219.63. That is my vector, which is a positive comma a positive. Oops. Erase that. So this is 197.89, 219.63. So if I want to find my magnitude, I'm going to do square root of 197.89 squared plus 219.63 squared. And when I do that, you should get 295.63 newtons for the force. Let me change it on my paper. And then if I want the degree, since we're in the first quadrant, that one's going to be easy. I'm just going to do tangent of theta equals my opposite over my adjacent. So you just need to do second tan in the calculator, and you should get 47.98 degrees from the horizontal.